Oh, fiddly-dee. For some reason, it's not seeing my webcam. I wonder what the deal with that is. Give me a second here. What is up with that? I want to use that. This is peculiar. Control Center, privacy and security. Let's see, Streamlabs, where are you? No, it's not there. Come on. No, I don't think that's the issue. Take a look at the setting on this. Come on, wakey, wakey. USB camera, for some reason, it is not, excuse me, not being recognized. That's okay. I'll just flip it over to the FaceTime camera. Okay. Done. Okay, that was weird. All right. Hey, good afternoon. It's Thursday, October 24th. I am still Rob, and I am still that developer dad. And this morning we started fleshing out some basic basic modeling for creating a flexible validation engine. And let me share my screen over here. Boop. And here we've got the rule expression that accepts an operator kind. Okay. And the operand type. And for evaluating the expression, well, we need to go into, I can close that. We'll expand rules engine, go into expression operators. We've got this operator base, right? And an operator base performs all of these operations against some type of T. So let us create a new class. So new file, class, and let's call it string operators. .cs. Boop. This guy is going to inherit from operator base of type string. All right. And it's just complaining that I'm not implementing things. There we go. So I feel like I should make all of my value to tests nullable. Because those values may be null. Save that. Now this is going to complain most heavily at me in a second because I gotta get rid of this. Florp. And operator base. Let's re-implement those abstracts. There we go. So, first thing we're going to do, if value to test equals null, we are going to return false. And then we're going to return accepted values.contains value to test. And we're using an IEnumerable of our type because I didn't want to use a list. I didn't want to use an array. I wanted some flexibility there. For is equal, I can very easily do return value to test equals base value. Now I feel like, can we compare a null to a base value? Well, I don't know. We're going to discover that when we start writing some tests. Return value to test is greater than or equal to base value. And this just runs an ASCII comparison. Oh, well, we can't do that. So what we need to do to determine whether a string is greater than or equal to some other string, well, what does that actually mean? For strings, we're just going to throw an exception. Throw new invalid operation, exception, strings cannot be compared using this operator. V. I don't know if I want to keep that. That feels weird. That feels really weird. String array, strings equals value to test base value. If value to test equals null, we're just going to bounce, return false. Here's that. Strings equals value to test base value. Strings dot sort order by descending. What are you complaining about? That's weird. What do you mean there's no sort? Oh. Array.sort strings. And is there a sort descending? What are you complaining about? Okay. Come on. Is it a function? Var sorted equals. And instead of doing sorted, yeah, okay. And return sorted dot first is value to test. Now that is not correct because we're looking for greater. And all this is going to do is it's going to sort by their ASCII value. Is greater or equal. If is equal come on, just go to the end of the line. Return true. Get rid of this white space. So if they're equal, we're going to bounce out all immediately. If our value to test is null, we're going to bail immediately. Just a moment, please. Yeah, apparently the Streamlabs or something in my setup is behaving stupidly today. So my background music isn't playing. Maybe if I restart loopback, just a second. Let me quit that and quit out of Apple Music. There we go. And now let me see if I can get this fixed here. Just take a second. I'm going to go back to single cam. Boop. Because I do like having that background music. Loop back. There's that. Let's just skip that for now. Bring up music. And I'm going to be careful to make sure I'm in my stream music because this is all certified for my use in this kind of thing. Play. Hey, it's back. I just had to fire it up manually for some reason. Who knows? Okay. So this is a little clumsy. I don't love it, but it's what we got to do for strings. So is greater than is essentially this, and I can get rid of the is equal evaluation. Now, instead of doing this here, can what? 9 of 12 is in the chat, just saying single words. Camera, oh yes, thank you. As soon as I lose track of what I'm doing or get distracted, I fall to pieces. Okay. Now we can shrink that. We can shrink is equal. Is greater or equal, instead of repeating the logic that I've got here down in is greater than, let's do this. Because this is really just sort of a compound either and or what have you. I can go return, and I'll surround that with some parentheses, is greater than value to test and base value, or else is equal value to test base value. And what this will do, and as a matter of fact, I'm going to reverse the order of those in that expression. Not like that, but like this. Because how this is going to execute, because is greater than is actually going to be kind of expensive computationally because we have to put these two strings into an array. We have to sort it in descending order alphabetically. And then if the first item in the array is equal to our value to test, then we can return true. That's a lot of stuff. Versus is equal, which is just a simple straight up equality comparison. And whenever we do the double pipe, this or else type thing, what that gives us is first it executes each expression in order from left to right. So first it executes is equal, and if it's true, we return immediately. If is equal is false, we say or else if value to test is greater than our base value, we'll return that. Excuse me. And we're going to be able to use the same logic or similar logic in our other stuff. Now, here we go. VS Code hides some things that I'm used to having access to. Is less than? You know what? Return not is greater than. All we're going to do is use the negation operator there. And we're just going to say return. Well, I should probably do my null check. No, I'm doing null checks elsewhere. And it says these parentheses are superfluous. I disagree. Return is equal, or else evaluate is less than. Now, some people would say we should probably inline these function calls, but because this is a compiled language and not an interpreted language, the compiler will likely inline this is greater or equal logic for, or this is greater than logic for me. And we're just using a little bit of link here, but that link will get converted into the actual algorithm that Microsoft invented for sorting things in descending order. So I'm not going to bother implementing a sort or anything like that. That's silly. There's no way I can build a faster one than Microsoft did, because they've got thousands of developers, many of whom are way smarter than me. So here's our string operators. Let's do a new class, integer operators. Oop. Okay. And this is going to inherit from my operator base for int. And I really wish there was a whole number base class in .NET. But we're just going to use ints for now. And we'll go ahead and implement the abstract class. And we want our value to test all to be nullable. Operator base, yeah, good. I wonder if instead of using the question mark on the parameter in the abstract methods, I should have done a nullable of t. I wonder what the difference is. You know what? Yeah, my ADD is acting up. It's like, instead of ADHD, it's like 90 HD today. But I'm curious about that. In .NET 8, is there any difference between the nullable glyph when declaring a variable and between using the nullable glyph when declaring a variable and explicitly declaring that variable as nullable like that way. For example, let's say I have a nullable int that I want to use as a parameter. Is there any difference besides the human readable syntax between expressing that as int or nullable int? And this gets into some .NET internals and stuff like that. And I've learned that when I get curious about something, it's a good idea for me to dig into whatever it is that I'm curious about, especially if it's just like this tiny little detail. And because sometimes I'll learn something that fundamentally changes an aspect of how I approach my code. And it just chase your curiosity, you'll get smarter. I promise. And according to Bing AI, which uses retrieval augmented generation against Microsoft Learn, because Bing is owned by Microsoft, Bing's really good about checking the base sources in constructing its responses to my questions. The shorthand int question mark and the more explicit nullable of int are functionally identical. The int syntax is simply syntactic sugar for nullable int. You can use whichever feels more natural. The compiler treats them the same way. And it boils down to readability and personal or team preference. So cool. I like using the nullable operator, so I'm going to keep using it. And if value to test is null, return false. Else, return accepted values dot contains value to test. No, I want to use link. Give me my string operators. Using system. System dot link. Boop. Copy that. Operator base. I don't need system dot link here. What even am I doing? Save that. String operators. What's this complaining about? Dot contains value to test. We use the null for giving. That doesn't make sense. Not a bit. File. Save all. Operator base. It's looking for, it expects T. You know what? I'm going to try something. What? Just explain that. Try to use a nullable T. But T is not constrained to be a non-nullable value type. Ah, int bool date time, etc. Nullable reference. Not allowed to use nullable of T with reference types such as string, object, or any other class type. Okay, so I have to use T question mark. Save. Integer operators. It's still complaining. Sometimes generics can get funny. Implement. That's so bizarre. So very bizarre. That's okay. These are intended to allow comparisons between actual values. We should probably do our null checks elsewhere. But whatever. All right. Now, dot contains value test. It should return me a bool. Yep. Return. And for some reason, it's working now. Return. Value test equals base value. I'm doing this ass backwards. That's okay. Return. I'll finish implementing this class and then I'll explain my reasoning here. Because we're dealing with numbers, we can do this kind of thing. There we go. Now, instead of doing this by type, I should be so operator base has all of these things, right? We don't need the operand type up here. I should be doing this instead of our operand type. Yeah. Need to get rid of this operator base of T. You're out of here. Public abstract bool is evaluate for T. public kinds, operator kind, get protected init, and actually it's not going to be a protected init, it's going to be a private init, ctor, not char, ctor, operator base, it's going to accept kinds, operator kind. This will be protected. Operator kind equals operator kind. What's this complaint? Oh, JNK's. And it's not operator kinds, it's just the singular form. That's going to be evaluate T. And we're going to use overloading. Save. So instead of integer operators, we're going to delete both of these. In a minute, I need to add a class equal operator .cs. It's going to implement operator base. There's that. ctor. And it's going to chain to the base class, passing the operator kinds equals. Get rid of those curly braces. And whenever I have an empty constructor like that, I always like to put the braces in line with the constructor declaration. It's just a visual thing I like to do. So evaluate T, T value to test, T baseline. I am not going to do this. I'm going to try public override bool evaluate string public override bool. No, you goon. That's what I want. And now let's crack open string operators. Not operator base. What the hell's the matter with you, Rob? String operators. Just going to grab the logic here. Yoink. Drop it in here. There we go. What's this? Let's go. String. I feel like it's still grumping. doing this wrong. Because I don't want to do a case when. That's goofy. All right, we're going to ask Copilot, copy, next question, inheritance with generics is really tripping me up. Here's my base class. What I want to do is implement the abstract evaluate method for a variety of types: string, numerics, dates, etc. I feel like I'm using the wrong approach here. Okay, so here's my base class, operator base. Derived classes for different types like string operator, numeric, and date. Ideally, I'd like to have one derived class for each kind of operator rather than a derived class for each type that can be evaluated. Say an equals operator class would be able to determine quality for a variety of types. Limit the type evaluation logic within each derived class. So here's this. Okay, so an internal strategy pattern. Use an internal strategy pattern then. Okay. And what we're actually dealing with here because this evaluate, all it is within the equals operator class, evaluate t, we are going to need some stuff in the body of this, because to evaluate t, what we need is a private read-only dictionary of type func object bool type strategies and there we go. That's all we're going to do there. And then register known type strategies. That's going to become a private abstract register known type strategies. All right. Oh, protected. That's right. Now let's come back over to the equal operator, and I need to create this private override. No, I think it must be protected. We're going to find out in a sec. Override. Nope. What are you doing? Let's just let the IDE implement that missing thing here. Protected override void, register known type strategies. So we have our dictionary of type strategies. We're going to register the known types. And when I come back, we're going to implement equality for string and int. And I'm just going to take like a 1 or 2 minute pause. Be right back. All right, I'm back. So register known type strategies. First thing we're going to do is func string bool string equality equals x, y, there we go. What are you complaining about? Dictionary of T, func, T, where T, default. It's not going to let me use generics. Gah. That's so weird. What did Copilot say I could do here? All right, so do you want a sketch of how the code would look? So evaluation strategy, bool evaluate, T value to test, T base value. Concrete strategy classes for each type. Operator base, operator kinds, abstract bool, return strategy dot evaluate, value to test, base value. So that's all right. But here it's passing in that evaluation strategy. Can I manifest each strategy expression as a func TT bool instead of a concrete class? Okay, first update the operator base class to accept a func parameter. Okay. And how about storing some common operator expressions in each operator base, storing some common type implementations, in each operator base for the common types instead of passing those in the evaluate call. Let the evaluate function look up the appropriate strategy based on the T on the call. Excuse me. operator kind, operator base. We've got the private static read-only dictionary, type, func, object, object, bool. So we've got all that stuff. Okay. Yeah, that looks okay. It's still dealing with everything as objects. So we've got to box and we've got to do some boxing and unboxing, but I can live with that. All right, so evaluate with strategy is a protected bool. All right, yeah. Yeah, let's give this a roll. Strategies.try get value type of T out for our strategy. Yeah, that works. That works quite nicely. Yeah, I'm going to basically take this and just use it whole cloth. But instead of the private static read-only dictionary of blah blah blah, I'm going to go object, object, get rid of this colon default because that was the wrong thing to do. And down here in register known type strategies, I'm going to get rid of this and basically type strategies.add. I'll grab this private static read-only thing that Copilot gave me. I'm just going to paste it in here for now. And all I'm going to do is copy this. Paste it here. Go back to the start. All right. Dot add. Because that's a long ass line of code, I'll do that. Type strategies. And we'll let that do that. Cool. Now, we've registered our known type strategies. We can get rid of this private static string. Goodbye. var evaluation strategy equals type strategies dot try get value type of T out var no. Ugh. strategy equals null. Throw new argument exception. There is no evaluator for type of T, and I need to give this operator kind dot toString, and that's not necessary when we're doing string interpolation. The compiler will add that for me. Operator kind evaluator for type of T, period. Otherwise, we're going to return strategy with value to test and base value. Let's add some short circuiting. If value to test equals default, of T, guess we can't do it that way, equals null. We're going to return false right away. We're not even going to try to do any of this nonsense. Or base value is null. There. Save. So here we're handling strings and decimals. I think instead of decimal, I might want to do double. Nah, we'll leave it at decimal. Okay. Now, that handles the equals operator. And when I want to handle more types, I'm going to do that and bring them in to, or add them here. Now, that's just for basic, primitive, well-known types. What if I want to be able to use this operator concept with other functions? So what I need to do is known type strategies, this, we're going to move this up to operator base. Now it's not going to be private, it's going to be protected. We're also going to move from the equals operator this up into the constructor for operator base. There we go. Protected abstract void, register no type strategies. Cool. Now, evaluate becomes exactly the same for every instance of our operator base, or every descendant of operator base. So we're going to cut that out of here. Go over to operator base, and instead of abstract, we're going to say virtual, which means it's overridable, but that's gone plumb crazy. I probably did something goofy. Oh, for sure I did. I left the semicolon up there. Where T presents a default. Okay, never mind. Jiminy Christmas. What even are you doing, you silly IDE? So there's that. So if we need to override evaluate on a descendant, we can. But if we don't have to, let's not. So we can 86 this. Goodbye. And now we no longer need any content in our descendant class's constructor. We can bump that up to the declaration line. Get rid of this stuff. And save. We've got the equal operator. Let's add contains operator. Wait, it's going to be a class operator. .cs inherits operator base. We have to implement some things. Register known type strategies. Okay. And this one's going to be a little weird. Let's not do contains yet. I might have to create a special subclass of the operator base for this. So we're going to close that. Don't save. We're going to delete you. Goodbye. Yes. All right. So we've written a whole pile of code We haven't gotten to see it run yet. So a rule expression won't have an operator kind. It'll have an operator base. And we probably need to add a using. There we go. Operator base. Now this evaluate, I wrote this one when I thought it was going to be something different. I started implementing rule expression. When I thought it was going to be, oh no, rule expression, yes. We're still dealing with an expression. So we've got the operand type, which is the type of T, operator base. All right. Rule expression, test value. And instead of operator kind, we can rename this to operator. Yeah, okay. I'll continue using operator kind. And all I will do is return operator.evaluate test value.baseline value. So a rule expression. Instead of operator base, I think I do need this to be operator kind. Yeah, it does. Operator kind. Operand type. Operator kinds. Okay. Now, the operator is really just a strategy factory, like our operator base, because the operator base specifies that we have a number of strategies to perform the operation across a number of types. And in our rule expression, the operator specifies which evaluation strategy we are going to use for this rule. We will be adding new operator kinds as we go, but for now, I think we can hard code this right here in our rule expression class. Yeah. Private operator base create operator. I'm going to pop this down on a new line. And, yep, operator kind, private, operator base, underscore, evaluation strategy. We're going to make it private read only. Evaluation strategy equals create operator for the specified operator kind. And we are going to switch on operator kind. Hey, what's up, Vengeance? How are you? I am doing some silly, wonky, hyper abstract C# stuff today. Case operator kinds equals, we're going to return a new equals operator. Now, we don't have any other operator bases declared yet. But as we implement, how's it going, Lisa? As I implement the different kinds of operators, just like I did with the equals, and set up their type strategies and all that stuff, we'll just add those to the RuleExpression method, or the RuleExpression class, in that create operator thing. Oh, my little beard is pure laziness. But thank you. And all I'm going to say is evaluation strategy dot evaluate using test value and baseline value. Save. All right, and these are good for single value rules. And this defines a rule expression for something. A rule base has a function name. Oh, my wife hates it. But thank you. This is unkempt, me not shaving, being in full goblin mode because I don't go out in public very often these days. All right, so a rule base has public type. No, not often. She's not a programmer. She'll watch my streams and stuff like that, but she doesn't participate. I'm doing like boring programmer guy stuff. Public type rule applies to get set. I think she's watching another stream right now. Rule applies to get, and this is going to be an init. And public string property name get init. You can give me a challenge, huh? Prop rule expression, I believe it needs to be. Yep. Public rule expression. Expression, get init. We need to import. Oh, it needs to be a rule expression of T. Rule base. System func base. Let's go to the definition on this guy. Ah, that's right. All right, what's your challenge? You can name your challenge, but if it's outrageous or ridiculous, I reserve the right to say absolutely not. Public abstract class system func base tu inherits system func base of u public abstract override u execute t subject I'll do that after stream. I'm not a big PDA guy. All right, so execute, doesn't like that. Gets rid of the body. Boop. Terminate that. And what else is it complaining about? All right. And CTOR. This also will be protected. System func base. String function name. Base function name. There we go. Excuse me. Save this, come over to rule base. And it needs to be T and rule, but not task. There we go. applies to. I need to be able to set that. Now on RuleExpression, doing that. Create operator, evaluate. I can probably demote this type argument down to here. Get rid of it up here. Get rid of the operand type, because I'm not worried about that. Okay. Save this. Pop back over to rule base. RuleExpression is expression. Instead of setting, rule applies to. I'm going to go back to my documentation on rules. Here we go. So a rule has a type of system object to which the rule applies, and where T inherits from system object base. Okay. It has a string value that identifies the property that the rule applies to. Boolean expression that must evaluate to true. Public excuse me. Doesn't need the type. Rule applies to, and then we need the property type because we need to declare that as the property type. V public V, no, type property type, get init, and I'll just set that in a minute. Public V expected, no, base value, get an init. And so we are going to have rule applies to, we're just going to return type of T, property type, type of V, and I need the lambda symbol, string, target property, V, base value. Property name equals target property, base value equals base value, and public virtual bool evaluate t-test value, and we're going to take return expression dot evaluate test value base value. And that should give us what we need there. We also need rule expression what else? Nothing else. All right, so we've got our public abstract class rule base. And I'm not certain that this needs to be abstract. No, I think it does. Class 1, we're going to rename. Yeah, Yeah, I am going a little long today. I'm like right in the middle of figuring something or getting this at least rudimentarily figured out. Like I've done this before over and over again, but it's been like every 3, 4, 5 years that I go down this code path. And I want to try and build something that I can reuse every time I need it because I need it more often than not. And I should use a pattern like this more often than not. But it's so much work to get it just right and generic and reusable that I often just end up hard coding my validation rules because screw it, this is too much work. But if I had access to a flexible, define my rules as data, pass it in, let it happen dynamically. I said I would do that after stream. I'm not a big fan of PDAs. But yeah, like if I have this as something I can just pull off the shelf and inject into an application, awesome. So I'm just going to call this sample type .cs. There. So sample type. New file. Class. Sample rule. And I need to give a reference to the rules engine and the framework. Also need project ref to the framework. Save. String operations, you can go. We're done with you. Don't save. So operation thingies, integer operators, operator base, string operators, these typed things, they can go away. Bye. Goodbye. Go away, string operators. Can I build? Will it build? Will it blend? Ah, yes, it will blend. I may not need this expression. There's going to be a lot of churn in this code here. But let's get rid of system func, base, RuleExpression, operator. All right, that's how I've abstracted all this stuff. Good. Equal operator. Do the type stuff in there. Operator base. See you later. Rule base. So sample type. Public class. Sample type. prop, string, name, prop, int, come on, prop, int, ID, prop, date time, created on, prop, decimal, I don't know. Count balance. Save. String name. We'll just implicitly initialize that to string.empty. And that's enough properties to be able to give it something to chew on. And we'll give it an empty constructor. What's this parameters crap? Go away. Sometimes Codium does some silly things. And we'll go CTOR, stop it. I want to add int ID, string name, account balance, assign all of these things. Name. Save all of that. Excuse me. Now, rule base, we don't need that. Sample rule is going to inherit from rule base sample type and string. Now, I think instead of sample rule, oh yes, sample type needs to inherit from system object. Boop. Save. Sample type and string. Implement abstract class. Yeah, I'm going to throw a new not implemented exception there. As a matter of fact, on system func base with a single generic, I don't even want public abstract T. That's got to go. It doesn't make sense to it doesn't make sense to have an execution without inputs. So this can go bye-bye. And sample rule is still unhappy, so we need to generate the constructor. Private read-only string rule name equals sample type name equals Bob. Super derived. Sample type name equals Bob. Cool. Function name I'm going to rename to rule name. The rule name is that. Target property. We don't need to pass that. I also don't need to pass any of these things. Because pass this as the rule name. What are you complaining about? Target property, base value, expression, private read only string, target property is sample type dot name, private read only string base value. Rule expression is a new rule expression. Of type equals. Boop. Save. Now, what's all this nonsense complaining about? Function name is rule name. Private. How about I do const? Target property. Not target property. Target property. Base value. expression. Can I use const? Nope. But no. I thought I could do this. Get rid of that nonsense. So that we can see all of this stuff here. Yep, I want that. I want that. And I want that. I'm going to name my parameters as I add them. And because this constructor doesn't really need anything else on it, we can do that. And then all execute does return base evaluate subject.name. Yeah. So save all of this stuff. Come out to my test app console, add a dependency. Project reference. We need test app types. Okay. Pop into program CS. Sample type. Test thing equals new sample type. Probably need to import some namespaces. Test sample. And I'm going to create another one, but I'm going to call it Bob sample. Var rule equals new sample rule. Okay, there we go. My AirPods kind of barfed on me. Well, they didn't barf on me. They ran out of juice. Var rule equals new sample rule. Bool. Result. Console dot write line. All done. All this is going to do visibly when I run this is just print out all done to the console. But we're going to step through this. And you know what? We're not going to break there.
because this X, I want to test the happy path first. So I'm going to comment that out. And instead of result 2, I'm going to call it the Bob result. And we're going to start step in here, save it all, debug. Is building. I don't believe I have any compiler warnings or errors yet, but here we go. So I'm going to step over this, and we're going to take a look at the Bob sample, make sure it's correct. So the account balance is 100, created now. ID is 1, name is Bob. We are creating a sample rule. Base value is Bob. Expression is equality, blah, blah, blah. Now I want to step through the whole stack of stuff I built. So we'll step in to execute. And return base.evaluate. So let's step in. We're into rule base. And here's our expression. Dot evaluate. Test value is Bob. Base value is Bob. So we'll step in. And we have our evaluation strategy. It's equals. Yep. So we've got our equals operator. And now we're into evaluate. So if value to test is null, it's not. Our base value is null. Okay, so if either of those is null, we're bouncing out. Because you can't actually compare null, because null literally has no value. It's basically all right, our type strategies. My strategy is in fact a method. It is not null. So that's good. We'll step in. String dot equals x is string, y is string. And it's just doing a ordinal ignore case. And we'll just step on out here. Bob result is true. Cool. Now let's comment out one that will fail. Save it all. Run it again. And I'm just going to do step overs here. So Bob result should be true. Good. Result should be false. And it is. And we're all done. That was 2 hours worth of coding work to do what I could have done in about 5 seconds. But tomorrow, we're going to start playing around a little bit with good old sample rule here. where we're going to make it a little bit more flexible. And instead of having to hard code one of these classes for every possible rule we might want to evaluate against something, I'm going to set it up so that we can push that stuff in through the injector. And we might have to go change some of the properties on rule base from being protected init. I believe that's what I've got. Yeah. So they should be protected init, not public init. But I might have to change these to protected sets instead of initialize only properties. But we'll get there. And then like up here in the rule base, I'll set them to some default value or whatever. Like I probably won't need the property type, or I probably won't need this to be generic once I start making these things injectable, and I'll use reflection to derive those from whatever the type of T and the named target property is. As a matter of fact, I may even take that out altogether when I get to that point. But we're going to start adding flexibility to this tomorrow is the bottom line. And then ideally we'll be able to just create a bunch of those things in a text file or a database or what have you, read them all in, and then create the validation rules, or the validations, which are nothing more than a set of rules that apply to some type within the context of some activity. So yeah, we'll get there. Until then, I have stuff to do. I need to do other things. I got to give my head a shake, and then I have some other code that I need to experiment with for something else. But until then, have a great night. Thanks for joining me, and happy coding. Take care, y'all.